Hey, hi everyone. So today we'll see the problem number 206, reverse linked list. That's a easy problem of Leetcode. That's a very classical problem asked in interview. So let's read the problem statement. So we are provided with the head of the singly linked list, reverse the list and return the reversed list. So basically whatever the reversed linked list would be, we have to return the head of that. So we have been given 1, 2, 3, 4, 5, right? 1 pointing to 2, 2 pointing to 3, 3 pointing to 4, 4 pointing to 5, and 5 to null, right? We have to return a linked list with a 5 as a head and 5 pointing to 4, 4 pointing to 3, 3 to 2, and 2 to 1, and 1 is pointing to null, right? So let's see how we can approach this problem, right? There are two ways to approach this problem. One is iterative way and other is recursive way. So first let's see how we can derive the iterative solution. So we are provided with this linked list and this should be reversed, which should look like this. So here this is the head and this is the head of the reversed linked list that we want, right? So how we can do that? Let's see. Let's consider the original linked list, right? In order to reverse that, can we say if we'll do a.next as null? So that can be achieved from this operation. Basically, this is the head. So head dot next equals null. But you see, if we'll do like this, if we'll do this operation, right? So this reference will be lost. So this will be pointing to null, and there is no way we can go to B. So let's do one thing. Let's keep pointer n as a next pointer to the next node of h, so that when the reference of a.next, h.next basically will be changed, we still have the reference to the next node, that is through n, right? Okay, that is fine. So a is pointing to null and b as the next, right? Now b should be pointing to a. So if we'll do n.next equals to h, right? So if this will point to this, so this reference will be lost. In this way, we lost the reference to this C node, right? So we cannot do this, right? We cannot do this. Okay, then what should we do now? Okay, so let's do one thing. Let's change this h to n. So I'm saying h is equals to n and n equals to h dot next. Can we do that? So if we'll do something like this is new h and this is n, h dot next, right? B's next is C. But in this, the problem is now the reference to A is lost. There is no way we have got a reference to A and we want B to point A. Okay, so let's do one thing. Can we say previous node, the head is the reference node, so whatever comes before, immediately before h will be our previous node, what comes immediately after h node will be our next node. So in this way we'll have the reference to the immediately next node, we'll have the reference to the immediately previous node, and in this way we can do h dot next as p, right? H dot next equals to p. If this will be done, so reference to this will be lost, but we already have the reference of C through n. So what I'm trying to say is we have a linked list A, B, C, D and null, and we have to reverse it, right? So let's call it h and n, basically head and next. We'll be using the complete variable name in the code, but it is just for understanding that I'm using these letters. So I'm saying h dot next equals to null, right? So this way this is pointing to null. Since this is done, so this reference is lost, right? So this reference is lost. Now we'll be doing h equals to n. So h will be this now, n will be h dot next, right? So n will be this, but since we are losing the reference of a, so what we can do is, before doing this operation, here somewhere we can write p equals to h. P is basically previous. So h dot next equals to null, p equals to h, that means p becomes this, and then h becomes n, that is this operation, n becomes h dot next. So this is the new n. Now what we can do is h dot next equals to p, right? H, this one, dot next, that means the pointer should be pointing to p, that is p. So this reference will be lost, but not exactly, because we have n pointing to c. So now we can say p equals to h, that means p can be moved ahead, h can be moved ahead, and n can be moved again ahead, right? In this way we are just keeping a reference of the immediate next pointer and immediate previous pointer. And this way, if we'll keep on iterating things, we can just reverse the linked list. And since this is an iterative approach, so until when we should be doing this? So we can do until h dot next equals to null, right? Until this is not null, we'll keep on iterating things. And for the initial case, if you'll notice, can we say that if nothing was present, let's say a, b, let's say c, until c we have this linked list, okay? Can we say this is initially p, and this is h, and this is n? Can we say like this? So that's basically demonstrates what should be initializing p with. So p will be initialized with null, h will be the original head, and the next pointer will be pointed with the n. Let's try to code this. So we have previous pointer, which will be initially null, and there will be a next pointer which will be saying as head dot next, right? And while head dot next not equal to null, right? So basically we will be going until head dot next not equals to null, right? So in case we have head dot next not equal to null, what we will be doing, we'll be doing head dot next equals to what? Previous, correct? And previous will be now head, and head will be now next, and next will be now head dot next, right? So you notice this will be terminated when head dot next equals to null. So basically a, b, null, this is h, this is n, and this is p. I'm just doing a dry run of our code. So this is h, okay? So h dot next equals to null, oh sorry, p, right? So this will be this, and this reference is lost. P equals to h, right? We have previous equals to head, head equals to n, head equals to next, and next equals to head dot next, right? So head will be this, next will be this, and previous will be this. You notice h dot next equals to null, right? H dot next equals to null, so this will break out of the loop. So you see, if this breaks out, you notice this pointing is not been done yet, right? This bridging of h dot next equals to p is not being done. In this case, if this is a while loop, okay, whatever the condition it is, if it comes out of the while loop, we should be writing h dot next equals to p, and then we should be returning head of the new pointer, new linked list, right? So basically we should be writing head dot next equals previous, right? And we should be returning head, right? Now there is one more condition. So here if you'll scroll down and you'll see the constraint, it says the number of nodes in the list is the range 0 to 5000. That means there is a condition that it might not contain any node at all, right? In this case, can we write if head equals to null, return head? Since if there is nothing, so there is nothing to be reversed, right? And accordingly, there is one more condition, that if there is only one node at all, so linked list with a single element is already reversed, right? There is nothing to be reversed. So in that case also we should be returning the same linked list. So we can write head dot next equal to null. Okay, in that case again we should be returning the same head, right? So this is the complete implementation. Let's try to run this. Okay, this runs well, so let's try to submit this. Okay, all test cases passed, right? So this was the iterative approach, what we did. And now let's see the complexity analysis of this iterative approach, right? So when you see, we are just processing one node at a time and proceeding to the next node, right? So basically whatever the head is there, we are processing that by not pointing to null, basically pointing to p, this logic, right? And we are just moving ahead with the head pointer, right? H pointer, we are moving ahead. So if you'll see, we are just processing each node exactly once. In that case, the complexity of this becomes length of linked list. And let's see now what will be the approach for a recursive solution, and why the knowledge of recursive solution is important, because sometimes the interviewer may ask you to explain or write the code for the equivalent recursive solution, right? So let's see how we can derive to that recursive approach. So we have a linked list as D and let's say null, right? We have been provided with this linked list and we have to reverse it. So let's see a few of the observation. So what if you are provided with this? This is already reversed, right? Okay. What about this? For these two nodes, can we say something like a dot next equals to a, or since for linked list this is a header, right? So can we write h dot next equal to h? So basically this a dot next is b dot next is null at moment, and we are trying to say b dot next should be a itself. This reference is lost. So a is pointing to b is pointing to a. Then in that case we can write h dot next equals to null. So this reference will be lost and this will be pointing to null. Okay, this logic is correct. Okay, now if there are 3 pointers, how we can do? This is the header. So if we'll do the same operation, okay, if we'll do the same operation, so a dot next equals to a, basically b is pointing to a, so reference to c is lost, and a dot next equals to null, so this will be pointing to null and this reference will be lost. But here if you'll see, the reference to c is completely lost, right? So can we say something like if a dot next b and c and null, so can we say if we have to reverse this, okay, reverse, so can we say this approach could have worked, if these two were reversed, basically this linked list would have been reversed. How? If this linked list would be reversed, how that will be? C, B, right? A is pointing to B, but from here C is pointing to B, right? It is reversed. In that case, we can apply this logic, right? A dot h, this is h, so h dot next is this, and h dot next will be null, and this reference will be lost. So we have C, B pointing to A and A pointing to null. We have got the answer, right? That means A, B, C, D and null. So if we have this reverse method, which will be eventually reversing this whole linked list with this as a head, that can be done if we can reverse this. Okay, after this is reversed, we can apply what? This logic. But in order to reverse this, can we say this can be reversed if C, T is reversed? So for that to work, can we say we can simply reverse D and null this linked list? And you see, for every method, whatever the initial node that we are passing is head. So in this example, C is head. In this example, D is head. But you notice that single element on a linked list is already reverse. So we can return. Now, what we need to return, that we'll see later, right? But we'll simply return this and we come to this point. So here it says in order to reverse C, D, first reverse D, but that is done. So then we can apply this logic. H.next.next equals to H and H.next equals to null. Basically here H is C. So C.next is D. D.next it's that it says should be a, I should be using different color. It says C.next is D and D.next should be C. And here you see the logic. Let's bring it down here. Okay. Yeah. So we have head.next.next equals to H. So D is now pointing to C. Now H.next equals to null. So C is pointing to null. Okay. Then again the reversal is done. We can simply return. What we need to return, let's see in later point of time. So here D is pointing to C, C is pointing to null, right? That's what we had right now. And execution of this is done. Execution of this is done. Both of the blocks are done. Now, since this is the header, head pointer, head node, so B.next. So B.next is C, C.next is should be pointing to B. So this is changed now. Now B.next should be equal to null. B should be pointing to null. So this reference is lost. Now we have D pointing to C, C pointing to B, B pointing to null. So B pointing to C, C pointing to B, and B pointing to null. Is that what we wanted initially, right? So now that we have A, we can simply reverse it by A.next is B, B.next should be H, and A should be equal to null. Okay, so this is D pointing to C, pointing to B, pointing to A, and pointing to null. Now you say what is expected as a return from this linked list? The head of the reversed linked list, that is D. So we'll be returning D from the here, right? And that's how we know what is to be returned from each of the method call, right? Here this, when method execution was done, it should be returning something, and that something is D itself. So the last node that is being processed for this particular case in our recursive call, we know that we have to return the last node because that will be the head. So that's why we'll be returning the last node, that is D in our case. We should be returning the last node, right? We should be returning D. In this case, after reversal, we'll be returning the same node, that is D. In this case, after applying this logic, right, we'll be returning the same node, D. And that's how it will work, right? So let's try to write the equivalent code for this. So let's clean this. Yes. And let's try to write the recursive solution. Okay. So what we are going to do, we are reversing reverse list head dot next, right? That's what we are doing. We are first calling that, from A, we are just saying reverse from B onwards, that is A dot next. And B is saying reverse B dot next, basically C onwards. C is saying reverse D onwards, right? So we are just reversing the next node onwards. Okay. After that is reversed. So once this is done, once this reversal was done, it was returned. What we did, we applied this logic, right? So let's do head dot next equals to head. Fair enough. And what we did now next is head dot next equals to null. Head dot next equals to null. Sorry. Now we should be returning the head pointer, that is the last pointer we had. We should be returning the last pointer, but from where we'll be getting the last pointer? You see, this method execution was sorry. So you see, when this method's execution was done, it returned D, right? The last pointer was D. So let's store this output of this method as const node. Okay, so this node will be the head of reversed linked list. Okay, and this is a recursive call, right? Reverse linked list is calling reverse list head dot next, reverse list head dot next. It will keep on iterating, so we need to end it somewhere. And where we are, when we are going to end it, we are going to end when there is just one element left, right? So you'll say if head dot next equal null, simply return the head, right? But as per the constraints that we have, as we can have 0 nodes also, right? In that case we can simply check if head equals null, right? In that case also return head. So in this way we can implement this recursive approach. What we are doing, we are just reversing this head. This head is saying, okay, reverse head dot next, and once that will be reversed, I'll do head dot next equals to head and head dot next equals to null, right? So let's try to run this. Okay, this is accepted. So let's try to submit this. Okay, again, this is accepted. Great. So let's see how we can compute the complexity of this. Okay, in this also, if you'll see closely, we are just processing each node only once. While coming to D, we are simply returning it. While coming, when this was returned, so operation on this node, basically this node CD is applied with this operation. Operation is applied on the head, right? And we are just processing each head only once, and that's when the complexity for this again become length of linked list. So this is the complexity of the recursive solution as well, but it's better to know the both approaches and how to derive them, right? I hope this is clear, and let's see in the next video. Thank you.